Okay, let's get started. So this is the first lecture of iOS development for fall 2020. I'm super excited to be kicking off the course with everyone, albeit in this new format. Yeah, so with that said, let's dive on in. So today's lecture is going to consist of an introduction, going through some course logistics, then talking about the tools that we will use to make iOS apps. Then we'll be going into a demo in a Swift playground, and we'll finish off with some action items, things that you need to do for this upcoming week. All right, so a little bit more about us. So this is Lucy. She will be leading next week's lecture. So I'll actually, have her introduce herself, but this is a slide showcasing some of the things that she does on AppDev. Okay, well, I'm Matthew Scullin. I'm a junior studying computer science. I'm a co-instructor with Lucy for iOS and a pod lead for CourseGrab. And previously, I was an iOS developer on Polo. Okay, so this is our awesome course staff for the semester. Everyone here is super excited to help you all with assignments, questions about lecture material. They will be holding, multiple office hours throughout the week, so they're really great resources. So yeah, please don't hesitate to reach out to any of them if you need help at some point throughout the course. Okay, so let's quickly talk about some course logistics. Lectures will premiere on YouTube at 7:30 p.m. on Mondays at the Cornell AppDev YouTube channel. So you can always access them at any other point, later on in the semester. We will be using Piazza for all our course communication. So please, be on the Piazza, just because a lot of information does go through there. If you ever have a question, you can make a public or private post. Please don't use email. Next is our course textbook, which is on Gitbook. This is like a centralized hub that has all our information from our syllabus, assignments, schedule, lecture materials, project handouts. It's really the heart of where all the info lies for the course. And so because we are virtual this semester, we have a new office hour system. We have a shared iOS Google Calendar with all the TA's slots. And there's a video on the course textbook that showcases how to actually schedule an office hours slot. So please look at that before doing that so it's done correctly. And in addition to office hours, Lucy and I will be holding a quick recap on Wednesdays at either 7 or 7:30. I need to double check that, but yeah, so that's a time to go over any questions you had from lecture, but you're welcome to use the Piazza and just ask there as well. We have a project each week, which is due on Sunday. We have one drop, except the two projects that you cannot drop is this first one, since we will be covering a lot of just basic Swift syntax, and it's really crucial to streamline the course later on, since you have like a fundamental understanding of the language we are working with, and the final hack challenge submission that cannot be dropped either. We do accept late submissions until the following Wednesday of that week with a 1-point deduction per day. If there are extreme extenuating circumstances, you can make a private post on Piazza and we can grant you an extension, but we also reserve the right not to when it's not warranted. Lastly, just a quick note on academic integrity. This is a course within the CS department. We hold academic integrity to the highest degree. And so, yeah, if we find out of any instances of cheating or anything that violates the code, we will need to report it. So please don't do that. It just hinders your learning and the things you'll take away from this course. Okay. So some notes on enrollment. The deadline to add is the 2nd of October. You need to enroll in CS 1998603, and you need to enroll for 2 credits. I think some students accidentally enrolled for 3. Just be sure to change that to 2. And once again, this needs to be done before the 2nd of October. Okay. Just going through some quick requirements. We're expecting people to have some familiarity with CS concepts, so either taking the Python course here at school or any just equivalent experience either from high school or personal learning will be sufficient. You need Mac OS, so either by using a Mac or a VM. We've linked to, I think this is VirtualBox, but there are a variety of different services that provide VMs. And you'll need Xcode 11 plus with Swift 5 in order to be doing all the projects for the semester. Okay, that's enough for logistics. Let's talk about how we actually make iOS apps. So we're going to be using a language called Swift. Swift is an extremely expressive, elegant, simple, and safe language. The other language that is used to develop macOS and iOS apps is called Objective-C, but it is much older than Swift. And this next slide sort of showcases some of its shortcomings. It's a lot more verbose and syntactically complex. So you can see the Swift example, we are making a constant myString equal to hello world, and then we are uppercasing all the characters within that string. The Objective-C equivalent, you have to declare the type beforehand with this NSS string. You have these @ symbols and semicolons after each line. So yeah, Swift is definitely a lot cleaner, and that's what we are going to be using. And as I mentioned before, you'll need Xcode. Xcode is the IDE for this course. It comes with a simulator, and it's really where all the work will be done for projects. Yeah. Okay. So with that, let's dive into a demo. So I'm going to exit the slideshow and go over here. So I have Xcode right down here. If I click this, we'll get this prompt that sort of says, what do you want to do? So we can make a new Xcode project, and we will be doing that for every other lecture and project. But since we are beginning with a playground, you'll just go to File, New, and click Playground. You can think of Playground as like a code editor of sorts, like VS Code, where you can just run short snippets of code, but you can't actually like make anything on the screen. And so you would click Playground and then select blank and make one. But because we're starting with some starter code, I'm just going to open up the starter code, which is right here. Okay, so let's make this full screen. Alrighty, so the first thing we're going to talk about is importing, in this case, UIKit. So like in Python, you can import libraries such as NumPy, or in Java, importing packages. This is how you import a framework into a file in Swift. And so this is an Apple framework called UIKit that we will be using extensively later on in the course to put UI elements, on the screen. So that's how that's done. All right, so let's talk about declaring constants and variables. So you'll see here we have this constant called netID, and we're setting it equal to my netID, which is MJS698. And then we have this variable called current year, and we're setting it equal to 2020. So these are like implicit declarations, which means we don't actually specify the type. Swift is able to infer that netID is of type string, and then current year is of type int. So this next line down here, we're actually modifying the value of current year. We're making this in 2021, and then we're storing it in current year. And so you'll see that if I run this, just to quickly show you, when you click run, the values of these variables will appear in this sidebar. They should. Just give me a sec here. Okay, that's kind of weird, but we'll revisit that in a second. And just to quickly show what's going on with the playground, down here is the console. This is where you can print out things like with print statements, which we will get into in just a second. Okay, so we have this current year variable, and we've changed it to 2021. Oh, that just took a while. There we go. Okay, so let's say we wanted to do the same thing for netID. Let's say we wanted to change the value of netID to a different string. Let's try ABC123. Okay, well, if I click run, it actually doesn't even let me run because netID is a let constant. So constants are immutable, and you can't change the value once they've been assigned once. So that's an important distinction to keep in mind going forward. Okay, let's talk about type annotation. So down here we have declared some more variables, but we've declared them with their types explicitly. So as you can see here, we have a variable called full name. Then we use this colon, and then we define what type it's going to be. So it's of type string, and then we set it equal to what we want to be. So in this case, we're setting it equal to my name, Matthew Scullin. When you do this, you don't actually have to set it equal to anything. Like I could just have first name of type string and then just leave it like that. And then I could actually set it equal to something later on. So first name is equal to Matt. So that's also perfectly valid. Just full name is doing it in one line. Okay. Then we have var month, which is same thing, but it's of type int, and we're setting it equal to 9. And label here is another variable of type UI label. And so UI label is actually a component from UI kit. So if I were to just quickly show you, if I were to get rid of this import statement, now UI label is no longer in scope. It doesn't know what type that is. So that's so that's why we need that import statement there. And now if we were to run it, it's going to be fine. Okay. And just to quickly show, let's say we wanted to have current year and actually assign it to be the string representation of the current year. So that should be 2020. Okay. So now if we were to run this, we can't even do that because this is a type error. Current year has been inferred to be type int. Now we're saying it's a type string. That's not allowed in Swift. Okay. Let's talk about printing. So if you ever want to print something to the console, you do it by typing out the word print, and then you want to pass in a string that you'd like to print out. So hello world. If we were to run this, you'll see that it prints out in the console right here. Yeah, okay. Now, let's say we want to print out something slightly more complex and actually include the value of a variable within our string. So let's say we wanted to print out the value of current year, right, 2021. Well, you can't just do like the current year is, and then our variable name, because Swift won't be able to differentiate that this is actually supposed to be the variable. It just thinks it's part of the literal string. Now, you usually in other languages, you can use like the plus operator and concatenate strings, but in this case, you can actually, in Swift, use this backslash and then parentheses and put them around your variable name. It'll be able to now isolate the variable. So now if we are to print this, it's going to say the current year is 2021. So that's a pretty nifty trick. Okay. Let's talk about arrays. So arrays are a very useful data structure that we will be using a lot going forward. And so these first two lines are just showing you different ways of instantiating an empty array. Now, specifically an empty int array. So you can't just have an array of any type. Otherwise, Swift, yeah, just it needs some, like, it's not able to infer or implicitly tell what type it is. So it needs an explicit type. So that's why we need of type int. This is using like a constructor kind of, you can think of it like that with like the parentheses like in Java. This is saying, hey, we're declaring this of type int array, and then we're going to set it equal to the empty array. Okay, so we have lecture numbers and lecture numbers too. Let's add something to lecture numbers. The way we do that is by using this function .append. So we're going to type out our variable and then use this inbuilt function called .append and then append something. Now, let's say we also wanted to append something else to our array, but have it be of a different type. In this case, once again, it's going to get mad at us because this is of type string, but we said this was an array of type int. Now, you can actually append both of these if you were to change this lectures numbers array to of type any. So now you have like a heterogeneous array, but that isn't something we will be doing, and it's really kind of jank. So let's put this back to int. But that's just to show you that it is possible, but yeah, not something that we're interested in. Okay, let's talk about appending through by using a loop. So let's say we wanted to append, as opposed to going one by one, we wanted to just use a for loop. So this is how you do for loops in Swift. We have the for keyword, and then you can think of num as like our iterator, and we're giving it a range. So from here, it's from 1 through 10, non-inclusive So that's because of the less than sign. So that's 1 through 9. Yeah, okay. And then here we have another for loop that is from 1 through 10 inclusive. And here we're appending to lecture numbers 2. So let's quickly, or let's keep going actually. Now we have 2 more for loops down here. And in this case, we want to print out our arrays. So if I were to remove this line, we're printing each individual element of lecture numbers, and we're printing each individual element of lecture numbers 2. So let's run this, and you'll see it, because print puts a new line at the end every time, it's printing down vertically, but we have 1 through 9, and then 1 through 10. So that's how you would print out individual elements of array. You can also just print out the array itself. So print lecture numbers, and that'll work. And there you go, 1 through 9. Okay, so let's say we wanted to remove something from an array. How would that work? Well, we use this function called .remove, and it takes in a specific index. So in this case, we're giving it 0, so we want to remove the first element of the array. And now if I were to print lecture numbers, you'll notice that it's no longer 1 through 9, it's 2 through 9, because we removed the first element. Okay, let's say we want to try to remove something from an array that isn't even there. So in this case, we have the empty array, and what we're going to do is try and remove the first element. But once again, it's empty. So let's do that. And you'll see that we get an index out of range error. So that's just something you have to be vigilant about when removing something from an array. Okay, let's continue on and talk about modifying arrays. So here we made a new array called course instructors, and it's a string array, and we've given it 2 elements already in our literal declaration. And we put in last year's course instructors, Omar and Yana, but now we want to update it to be this year's course instructors. So the way we can do that is by using or accessing the previous index in the array and then updating its value. So here we're doing course instructors at 0, and we're going to replace Omar with Lucy and Yana with me. And so now if we were to print out the value of course instructors, you'll see that it's Lucy and Matthew, whereas before, if I just quickly comment this out, it's going to be Omar and Yana. Okay, so what happens if we try to modify an element of array that isn't there? So once again, we only have 2 elements, 0 and 1, in course instructors. What happens if we wanted to try to modify something that isn't there, in this case, index 2, which is really the 3rd element? If we do this, you'll see that we get another index out of range error. So something, once again, that you have to be careful when modifying. Okay, and as I mentioned before, this is, I think it's just a repeat. You can use append to add to an array. There's a bunch of useful functions. You could use, like if you ever want to get the count, like how many things are in your array, you can just use count. Yeah. Okay, let's talk about dictionaries. So dictionaries is another data structure that uses key value pairs. Basically like a mapping, every key has a value. And so like our array example, here are the 2 different ways you can initialize an empty dictionary. You can either use the constructor or declare its type and then assign it to the empty dictionary. And that's done by having the brackets and then the colon. And so just in this specific example, pantry and pantry2 have keys that are of type string and values that are of type int. So let's say we wanted to add something to this dictionary. We do that by referencing our variable pantry and then using brackets and putting in our key. So our key is a string, so we're going to have apples, for example, and have that equal to, which is our value. Okay. Now, if we wanted to modify apples, all you have to do is do the exact same thing with your new value. And because you need to have like unique keys, it's not going to create like 2 apple keys mapping to 2 values. It'll just change the existing one. You can also create a dictionary with like literal key value pairs. So that's what we've done here. We've just made pantry2 equal to dictionary with 3 things, apples 10, oranges 5, and chocolate bars 2. Okay, so what happens if we want to iterate over a dictionary with a for loop like we did with our array, right? So, and we want to print it out. Well, since there are two key value pairs, we need to have like two things that represent the key and the value, if that makes sense. But everything else is the same. You use the for keyword. If you're using numbers, like our first example was with like a range of numbers. But if you're doing it for every element in an array, you're using the variable lecture numbers. In this case, we want to go through everything in pantry 2. So that's what we're using. And then if we print this out, we're using that string interpolation trick from before, and it'll actually print out everything in our pantry. So I have 10 apples, 5 oranges, 2 chocolate bars, and know that this order isn't necessarily the same order that you initialized it in. Um, Dictionaries are like random where their keys are. Okay, let's talk about functions. So this is going to be a core of any language, but especially with iOS apps too. Let's say we want to have a function that prints something. So every function begins with the keyword func and the name of the function. And every function has parentheses. Now within the parentheses, you put in your arguments. In this case, we don't actually have any, we don't want to pass in any arguments. So it's just nothing's inside the parentheses. And then the body of the function is denoted by these curly brackets or curly braces. And then we actually put the body of the function inside. So here we're just printing something. So if we run that, you'll see that we actually print out something. Oh, no, it won't, because we haven't called it. So yeah, let's actually call this function, right? Print something. Okay. So now let's call it, and now you'll see that something has printed to our console. What happens if we wanted to print something, let's say the caller actually wants to print something that they have. So we would want to actually add, pass in an argument. So let's do that. Let's pass in a string, and then, print out whatever that string is. So here it's going to say missing an argument for the parameter. So let's actually change that to be, I don't know, test. And you'll see that now it'll actually print out something test. If you put this underscore in front, this is just a weird Swift thing, you can actually omit the parameter name and just pass in the string directly. So it'll still do the same thing, but you don't have to actually put str in front. But let's just go back to how it was before. Okay. All right, so now let's talk about more functions. So here we have an add function that takes in 2 parameters, a and b, which are both int, and we actually want to return something. So this previous function didn't do anything. You can think of it as like a void function in Java. It just prints something to the console. Let's say our function wants to return a value, in this case the addition of these 2 numbers. We need to specify return type. And so that's what this is right here. We have this arrow and then the return type, which in this case is int. And so now you can see down here we're calling these 2, we're calling this function add twice, and we actually are storing the result in these constants, add 2 and 3 and add 3 and 4. So if we're to run this, you'll see on the side panel here, 5 and 7, those are the correct values, right? Because 2 plus 3 equals 5, and 3 plus 4 equals 7. So that's exciting. You can actually even do more with this. You could give these default values. Like let's say the caller didn't actually put in numbers. It just called add with nothing. So let's put test equals add, and they put absolutely nothing. Then test will just be 0 because we've defaulted these values to be 0. So 0 plus 0 equals 0. All right. Let's talk about structs and classes. So, we will be using models within our code bases to represent different objects, and we do that by either declaring structs or classes. So right here we have an example struct called episode. Now it has some properties or fields. It has a name, type string, and a duration of which is of type float, which is int with like decimal points. Okay, so now let's say we want to actually create an instance of our struct episode. We can do these two lines show you how to do that. We have, you can either have a constant or a variable var episode 1, and then we're going to set this equal to the episode. So we're referencing our actual struct here, and then we need to construct it by passing in things that we want to assign to our properties or fields. So in this case, constants will be the name, and the duration will be 10.0. And the same thing for episode 2, except it's functions and 12.0. So that's structs. Now let's talk about classes. So here's an example of a class declaration. And this is a class called podcast, which has a name, and episodes, which are of type episodes. So you can see here we are referencing, this is an array, and the elements of that array are of type episode, this struct. With classes, you need an actual initializer. If I were to take this away, you wouldn't be able to actually make and instantiate a podcast. And so it says podcast has no initializers. So you need that for classes, but not for structs. And like in any other language, you can have functions within a class. So here we have a function called play podcast. It doesn't return anything. It just prints out to the console the name of the podcast. And you can also do this with structs. So this could have a function, called length or something that takes in nothing and just outputs the, print duration, right? So you can do that with structs as well. Okay. And so right here, we are just showing you how to make an instance of a podcast class. And so it's the same thing as a struct. We want to initialize, our constructor takes in a name of type string and an episodes array. So we're saying the podcast name is intro to iOS, and the episodes are the array containing the first 2 episodes that we instantiated over here. This could be the empty array also, The big distinction between structs and classes are that structs are value types and classes are reference types. So let's talk about that a little bit more. You can see right here, I have made another episode called episode 3, and we called it structs, and the duration is 5 seconds. And then I've made another episode 4 and have set it equal to episode 3. Okay, so what I now do is I set episode 4's duration to 14.3. Now, because structs are value types, when we assign episode 4 to be episode 3, it basically copies the value of episode 3 struct and then puts it inside episode 4. So I'm going to run this, and maybe this will make a little more sense with this example. You'll see that we made episodes 4 duration equal to 14.3. And so, simple enough, that makes sense that episodes 4 duration is equal to 14.3. But episodes 3 duration is unchanged. And once again, that's because what happened was you can think of episode 4 and episode 3 as like 2 distinct objects. When we set episode 4 equal to episode 3, we copied over what was in episode 3 and put it in the variable episode 4. So let's see what happens behavioral-wise with classes if we do the same thing. So we have this class, or we have an instance of podcast, or we make a new podcast, and we're going to call it stored in podcast 2. And now we have a variable called podcast 3, and we're going to set it equal to podcast 2. So now we're going to change the name of podcast 3, okay, to a newer podcast. So what do you guys think is going to happen if we print out these, the names of podcast 2 and podcast 3 now? Well, if we run this, you'll notice that both of them have changed to a newer podcast. So unlike structs, where in the struct example, episode 3's duration was unchanged, but here, podcast 2's name was unchanged. And that's because classes are reference types. So podcast 2 is actually a pointer to the podcast object that's stored somewhere in memory. And when we initialize podcast 3 and set it equal to podcast 2, we're actually just giving it that same pointer. So now both podcast 3 and podcast 2 are pointers to the same object in memory. So when we change, the name of podcast 3, it's going to that location in memory and changing it to a newer podcast. So, and because both podcast 2 and podcast 3 are pointers to that location, any change that's made will be reflected in both of them. So that's that's the main difference between structs and classes, and something very important to keep in mind. All right, let's talk about optionals. So you'll see here that we have this variable called input string. It's a type string, and we set it equal to hello world. If we try assigning input string equal to nil, we're not going to be able to, because nil is not of type string, right? That's not allowed. It's going to cause a type error. But this following example, we have this variable called optional string, which is of type string, or an optional string. And the way you denote that is by putting the question mark behind string. And you'll see that in this case, if we run this, it's perfectly fine. We were able to assign nil to optional string. So you might be thinking, oh, well, okay, well, what's the value in that? Well, oftentimes in iOS development, you will run into optionals because there are many times when you can't guarantee a value for something. So, you might have an app where a label only appears certain times based off of like some condition, right? And you need to be able to handle both cases, when it is something and when it isn't, okay? So you might think, okay, well, we could just make like an if statement, right? We could check whether optional string is not equal to nil, and if that's the case, then we'll do something. So this is like an if block, right? But this isn't like the Swift standard. It's not incredibly safe, and Swift has its own way of doing it, and we're going to talk about that right now. It's called using an if-let. So you'll see here we have this optional string, once again, called equal to hello world. And the syntax is doing if let unwrap string equals optional string. And so what this is basically saying, this is just an arbitrary name. The reason why we put unwrapped is because when optional string is not nil, it gets unwrapped to a value, and then we store that value in unwrapped string. And then within these curly braces, we can do things with this new let called unwrap string, and we are guaranteed for it to be a value. So that's what's powerful about this. So you'll see that we print out the value wrapped in the optional string is hello world. But if we were to change this back to nil, then nothing's going to happen, right? Oh, that example is also done right here, so I didn't have to type that. But the point is made that you won't enter this if let block if optional string is indeed nil. So you can think of it as like a safeguard. If you ever want to act, if we go back to that example with the label, if the label does exist, then do what you want with the label within this block. Okay, so you can have optionals of any type, optionals, strings, ints, and you can do if lets with multiple things. So in this case, we want to unwrap both optional 1 and optional 2. We want to make sure that they both, are not nil. And so you can see that that's what this if let's doing. It just has like a chained if let of sorts. And you'll see that we print out some string and then 4 in our console. So that's working. The other way that we can ensure that things are not nil when we are dealing with optionals is with a guard let. So let's say we had a function called unwrap that takes in an optional string, and let's say this function is dependent on this thing actually having a value, as opposed to an if let where if it does have a value, you then do all the work that you want on that thing. Guard lets sort of do the opposite. If it is nil, then we will quickly do what we need to do if it is nil and return, exit the function. But then the rest of the function body is not actually, in these curly braces, is free to use unwrap string however it wants. So you can kind of think of it like if lets within these curly braces is like the safe haven where it is not nil. Guard lets is the opposite. Within the curly braces is the case where it is nil, and then everything else is is, you're guaranteed unwrapped string to, to actually have a value. And so we can call unwrap the function. This is in a function. And in the first case, you'll see that guardlet returns out of the function, right? Because we passed in nil. But in the second case, if we run that, you'll see that it actually evaluates this guardlet and then doesn't go into this else block and goes into the main function body and prints out, now I can use the unwrapped int, which is a value of unwrapped string. So that's guardlets. You can also, with optionals, do something called a nil coalescing operator. It's basically a default. So for optional string, let's say if it is nil, let's just give it a default value. So that's what we're doing right here. We have this constant called unwrapped string with default value. We're setting it equal to optional string. But in the case when it is optional, we'll use these two question marks, and that denotes a nil coalescing operator, which will give it the default value if it is nil. So you could do this with ints. So if we had an optional int, so let's say optional int of type int optional, I'm going to set it equal to 3, right? Then we could have an unwrapped int, and we could set this equal to optional int. And then if it is nil, we could just give it the default value 0 or something like that. So that's just another example with a different type. Okay, great. Okay, and so this is just an if-else block in the case that we actually, this thing actually went to the default case. So in the case that optional string was nil, it became equal to default. So when it's equal to default, we know that the original optional string was nil. So that's basically what this is doing. So you'll see that the unwrapped string was nil because optional string, wherever we last assigned it, is equal to nil. Okay. You can also do something called a forced unwrapping. And so that is basically saying, I am confident that this optional actually has a value. So you'll see that this print statement, as opposed to using a nil coalescing operator doing an if-let, we are using this exclamation point. And that's saying, I know that there is something within this variable that is not nil. Now, that's powerful, but it's dangerous, because if you were to force unwrap something and it was nil, this will be very bad. And this could potentially crash your entire app. So you need to be very, you need to use this seldomly and only in very specific cases where you can guarantee that something is never ever going to be nil. So I will show that by what happens by uncommenting this other print statement and running this. So in this case, the forced unwrap string is nil, and boom, blows up in your face. You get a runtime error. And so that's what we want to avoid, because something as simple as that could crash an entire app. Okay. So we're going to quickly reference back and sort of connect the dots with dictionaries. So let's go back to Pantry, right? Pantry had, I think, like apples in it. So, but it didn't have pears. We never added pears into it. So here's a classic example of where optionals come up, right? Let's say we wanted to print out if we actually have pears in their pantry, right? But we don't right now. So when we run this if-let block, oh, I'll just uncomment that print. Nothing's going to get printed, right? Because pantry pears is nil, so we won't enter this if-let block. And you'll see that nothing was printed. But in the case where we do have something, because we did add apples, we will print out, I have whatever value is, which I think is going to be like 4. Yeah, I have 4 apples, and you'll see that right there. Okay, so that's an intro to optionals, and you'll be getting more practice with this in this week's project. We're going to finish off with just quickly touching on enums and case statements. So enums, like in any language, is a great way to sort of categorize things that are related. And so here we have font size, and we have our different cases, which are going to be small, medium, and large. And so here's how we can sort of create our enum. So we have these different constants that are now equal to our different cases. And there are different ways you can initialize them. So this one's directly, this one is saying it's going to be of type font size, and then actually giving the font size medium, and same thing with this one. So you don't actually have to explicitly reference font size, as in large we don't. So these are just different variations of instantiating. So let's say we want to print something based off of what size we were. That's where a switch comes in. Switch case comes really handy. We have this function print for size, which takes in a font size, and we can use this switch, which will basically go through all the possible cases, and then we can isolate cases and do varying things based on what it is. So in this case, we're printing out different things, but in your app, you might want to do one thing or display one button if it's this thing, and display another button if it's something else. So you can see we have case.small, case.medium, and then we have a default case. So you'll know that this isn't exhaustive, right? Or it is exhaustive because we have a default case. But if we were to remove this, the switch case doesn't capture all cases, right? Because there's a case large. And you'll see that Swift will tell us it needs to be exhaustive. So case we'll add, as opposed to having a default case, let's add large, right? And let's print I am large. Cool. So if we print now, if we call the function print font size with large font size, you'll see that it prints I am large. And you can also have a default case. So right here, we have now added a default case. So if it was neither small, if it was neither medium, if it was neither large, it would just go to I don't know. And so this is like just a wide net that catches anything. And in this case, default will never be executed because we've already exhausted all our previous cases. But if we were to remove large, then default is what would get printed. So if we were to now run this again, it'll say, I don't know. Yeah, so that's just a quick intro to Enums. Let's now quickly exit this and go back to our PowerPoint. Okay, so that was it for the demo. This was just to sort of get you acquainted with basics of Swift syntax, and we'll sort of prep you for the following lectures, and your project will just be an extension of this playground by working with a variety of different types and data structures like dictionaries and stuff, and making some classes and structs. Okay, so action items. Okay. Well, we want to make sure you're enrolled because the deadline is October 2nd, so please do that and add yourself to the Piazza. And the Project One handout is in the course textbook. So just go to the textbook, navigate to Project One, which is intro to Swift and Xcode, and then download the starter code, and then start filling it in. This is due September 27th, Sunday at 11:59 p.m. on CMS. If you have not been yet added to the CMS, I think the majority of you have, just make a private Piazza note and we will make sure that that is done. That is it for action items. And that is the end of lecture 1. Thank you all.